Hey guys, welcome to the fourth Banguino project. In this project, we are going to use an inertial measurement unit, or commonly known as an IMU, to measure the orientational data of an object in 3D space. The setup is very simple. We have with our Banguino board, then a 20 by 4 LCD screen. 20 by 4 LCD screen means it has a 4 rows and 20 column, and the powerful 10D of GY86 inertial measurement unit. In this board we have an accelerometer gyroscope in one package. This sensor is called MPU6050. Then we have HMC5 883L 3-axis compass, and our barometer over here. So let's start the system from beginning, resetting it. This is a intro message. I have written a small routine of hardware testing. I should emphasize that hardware testing is very important in this sense that if say your MPU6050 on that board was not working, then it would be no point of moving forward because all the data would have come wrong. And we can see there are four. I've used all the 4 rows here to represent 4 different data. The first one here is pitch. It means the rotation of the body along the x-axis. Then it is the roll. Pitch is the rotation with respect to y-axis. Roll is the rolling of the object with respect to an x-axis. Heading is heading is the direction which the body is facing with respect to Earth's North Pole, and altitude is a combination of pressure and temperature reading to get the height of the body from the sea level. For this experiment, please don't focus on the altitude. The main three orientation data are this: pitch, roll, and heading. Now, as you see, when I take the inertial measurement unit and tilt it forward, the pitch value is going down. That means the body has fallen along the front side. If I tilt the body IMU back, the pitch value becomes greater. That means the body is tilting backwards. Now I bring it back to center position, and then I roll the body to right, the value decreases, and rolling it to the left, the value increases, and as such. Then the heading is, let me show you. I am rotating it to the right, the value is increasing. I'm rotating it to the left, the value is decreasing. The sensors on this IMU board gives fairly accurate reading. I got this sensor for an quadcopter project. It's still going on. The idea is that the quad will use the data of roll, pitch, and heading to find find which side it is falling off, and to perform and do the correction of the motor speed so that it can stay level. That means in level condition, the system will try to maintain itself along these two readings. As you can see that it was supposed to be 180 degree and 180 degree for both cases, but as you will know, accelerometer is very prone to vibration, and it can feel vibration. For instance, see, it feels vibration. The vibration actually causes it reading to jump significantly. But however, in this case you saw that the vibration didn't cause too much problem. The reason is that I am using a Kalman filter. It's a very powerful and filter algorithm which is mostly used with gyro accelerometer combination. And lastly, you see that the altitude reading is very fluctuating. The reason is that the altitude, the barometer, the white, hope you can see that the white sensor here, it depends greatly on the pressure and temperature value, and but in our case, the code, we have inputted a value, a standard pressure value, that is 1.013 10 to the power 5 Pascal. However, this is not right for the case where I am now. But however, to find the value, the real pressure value, you will need other instruments which are not available with the IMU board. But it's not the concern, because say you're building a balancing robot, a balancing robot. What it will just need is the first two value, pitch and roll. Because say the robot is trying to tilting forward, what it just need to do is increase its reverse the motor speed, so that the motor tries to bring the body back, and ultimately just doing this correction for 2 and 4th, it will maintain its position. There are tons of documentation regarding this particular inertial measurement board GY86. I have also provided some. Well, that's it. I have not used the HD card here, but if you want, you can record the data in the HD card, as I've shown in my last shown in the last experiment how to doing it. But I should emphasize in one thing: if it's not a good idea actually to display the data of IMU to LCD screen like this, because even though the data are shown very nicely, actually there has been a lot of trade-off to get this speed, and I'm actually bottlenecking the microcontroller unit and locking its more manifest potential just to get up to this speed. What you could do is, if you need to display it, I suggest you going with an SPI or I2C LCD screen, which will greatly enhance the performance in this sense that microcontroller will need less amount to work and can communicate much faster with those LCDs against this one, because it uses only 4 bits in the LCD library that I have used, which was provided by Arduino. This is actually very small, has a very low refresh rate. Even though we are able to see it quite clearly, I have actually maxed it out this refresh rate on, I think it's 20 Hertz highest it can go, but the microcontroller can go much faster, or be able to do much faster refresh rate. However, it has to slow down both its data acquisition from the IMU and its counting capabilities just to match this refresh rate. I strongly suggest, if you need to show value to an LCD screen or GLCD, get one which has a higher refresh rate. That's all. Thank you for watching, and hope we'll see you again. Thank you.